Section 5.2, they're asking me if problem number one, and number one is we need to prove to show that cosine of x, cosecant of x, and tangent of x equal 1. And the question is that an identity? Well, first of all, based on what I know, I can use the stuff that I know. What do we know about any of those three? And start making a plan is, try to have everything like in the same thing so we can cancel out as much as we can. So what can we rewrite? That's a good idea. So cosecant, so cosine, we just leave it like that. Cosecant is 1 over sine. Great. And what else? There you go. Since I'm using cosine and sine already, well, might as well just rewrite tangent as sine over cosine. So here, I can cancel, what can we cancel? The sine of x with the sine of x, this is one on top, one on the bottom. What else? Also, the cosines can cancel out. So is this an inequality? And yes, it is. This is an inequality. I mean, an identity. Identity. Okay? Now, problem number two. Number two, we have to prove that sine of theta times secant of theta equals cosine theta, cosecant theta. Okay, so is there going to be one that is not going to be an identity? Sure, it could. Okay, but let's see if we can make this an identity. Okay. So what can we do here? By the way, you cannot move things from left to right or from right to left. We're not solving. It's got to be line up, going down, going down. Okay, so what can we do? Okay, secant is 1 over cosine. That's right, Osil. So secant is 1 over cosine. So let me just leave this the way it is. What about on the right side? There you go. Cosecant is 1 over sine. Okay? So I'm working on both sides, left and right, but going down. So what is on the left side and what is on the right side when you simplify that? That's right. This is just sine over cosine, which is just tangent. And on the right side, that's cosine over sine, which is cotangent. So is the left side equal to the right side? The answer is no. So you put just a line crossing out that equal. They're not equal. So here we just put not an identity. Okay, now you go ahead and try number 3. So here, I rewrite the secant as 1 over cosine squared theta. I multiply, I got sine over cosine, and that is tangent. And if you look at the formulas that you have, the identities, if you look at that 1 plus tangent square of x, is that equal to secant square of x? It is, right? That is the second identity, which is this one. See, this is equal to secant square of x. So when you rewrite that, you're going to have, that is just secant square of x, God bless you. It's equals to secant square of x. So notice that I wrote everything from here down the same thing. I have to rewrite it and rewrite it, or just put a line, an arrow pointing down. And at the end, just make sure you rewrite it, okay? So don't stop here. Not because you know that this is a true statement, you stop there. No, you rewrite, you know what this is equals to, which is this, just rewrite it over here, okay? So at this point, you can say this is a true statement, that's an identity.
secant from tangent?
Because over here on my identities, the Pythagorean identity, it tells me that 1 plus tangent square theta is secant square theta. So I'm just replacing this part for equals to this. Okay. So it is an identity. Okay, so now let's go ahead and work on problem number 4. So in problem number 4, number 4 is cosine square of x minus sine square of x. That equals to 1 minus 2 sine square of x. And this is one of those that I still remember when I was taking calculus in college. It was one of those that I needed to prove. So any ideas on how to prove that this is an identity, that the left side equals to the right side? Any ideas? No?
Use the Pythagorean identity.
Yes, you may. Yes. That's a great idea. If you look at the Pythagorean identities, notice that the right side is in terms of sine. So what you don't want is to have cosine on the left. So if you look at the Pythagorean identities, see, cosine can be rewritten as sine, which is all of this here. Okay, so in place of cosine square of theta, I'm going to put 1 minus sine square of theta. Okay, so I'm going to use that. So in place of cosine square of theta, I'm just going to write 1 minus sine square of x. And this is minus sine square of x. And that equals to, and I'm just going to break this down. Now, since I don't have anything outside the parentheses, I can just erase those parentheses, okay? Because I don't have anything there. Okay? Have a good afternoon. So, can I combine the negative sine square of x and the negative sine square of x? Yes, right? Because I have negative, it's like negative 1 sine square of x and negative 1 sine square of x. Well, that makes it 2. So that's going to be 1 minus 2 of the sine square of x's. And that's what you have on the right side. So this is an identity. This is true, and this is an identity. Okay? Now let's go ahead and move on to number 5. And number 5, you don't need... In problem number 5, it's sine of x times tangent of x, and this is cosine of x minus cotangent of x, cosine of x equals, let me just, this is so long, let me just move it this way. Okay, so on the right side I have 1 minus 2 cosine square of x. So any suggestions on how to target this problem? The tangent, rewrite it, and what else? And the cotangent, right? So the tangent and the cotangent, let's rewrite that. So I'm going to rewrite sine of x. The tangent, we're going to write that as sine of x divided by cosine of x. That is being multiplied by cosine of x. Since it's a fraction, let's put the other one as a fraction, minus. The cotangent is cosine of x divided by sine of x, and then times cosine of x. Okay, that equals, and let's see if that could be equals to the right side. Close parenthesis over here. Okay, so now, what else? Can we simplify something here? The cosine of x and the cosine of x can cancel out. Okay, so let me just rewrite what I have. So this is going to be sine of x parentheses sine of x minus cosine times cosine is cosine square of x divided by sine of x. And let's see if we can let it equal to the right side. Now that sine of x is over 1. What else can we do? The sine, which one of the signs? Because we have 3 signs. Outside, the first, inside, in parentheses. What can we do with that?
Cancel it out.
If it were to be multiplying, like if that was to be, if this part right here was a times, then we can cancel it out. But this is not a times, it's a minus, it's subtracting. If we combine them, we need to have a common denominator. So that's a good idea. What's going to be the common denominator for this? The common denominator, it's sine, right? Because these two can be, like this one, we have to change it into sine. So in order for us to change this into sine, we need to multiply top and bottom by sine, okay? So let me multiply top and bottom by sine. So this multiplied by sine of x, this multiplied by sine of x. When you multiply by that, you're going to have sine of x, parentheses, sine square of x minus cosine square of x over sine of x. Okay, so I combined both of them. That was a good suggestion. Now what else?
Since you're dividing by sine of x, you cross out the square.
That is right. Well, which square are you talking about?
Just on sine.
Just this sign right here and this sign over here. Since this is over 1, we can cancel those two. This is dividing, this is multiplying. There, you can cancel them. So yes, you can cancel those two. And so you're going to have sine square of x minus cosine square of x. And that's supposed to be equal to 1 minus 2 cosine square of x. So now what? Any suggestions?
You move the 1.
We cannot move things from right to left. Okay, it's only you always go on a column left, keep it on the left, the right, keep it on the right. See what you can do here, and you were looking at the formula chart, right? Yes. On the Pythagorean identities, notice that you have cosine square of x, sine square of x. What we can do is we can change what is it that we have on the problem. We have cosine on the right. So we can rewrite sine in terms of cosine. So in place of sine square of x, we can just put 1 minus cosine theta. Okay? So I'm going to use this right here. So I'm going to use, instead of the sine, this right here, I'm going to rewrite and I'm going to put, that is the same thing as 1 minus cosine square of x, and then I just rewrite the rest of the equation. Okay, so we're almost done. Can we say that this is just minus 2 cosine square of x? It is. It's just like the other problem that we just finished. So 1 minus 2 cosine square of x is equals to 1 minus 2 cosine square of x. So this is a true statement and this is an identity. So that's a proof. Any questions about that problem number 5?
We didn't just cancel out the sign for the third step or for the second?
On the second step, can we cancel the sign on the second step, like from here? Here, see, the thing is that this needs to be over sine in order for us to cancel it, because this one only, like this one with this one will give you probably cosine square of x, which is, oh, it's not here, well, sine square of x, which is this one. You could have distribute like that. And if you were to distribute, you're going to have sine square of x. If you distribute, this cancels with this, and that's going to be negative cosine square of x. So you could have saved, the combining. You could have done that too. Yeah, okay. Okay, next problem. Number 6, it's cotangent of x divided by 1 plus cosecant of x equals cosecant of x minus 1 over cotangent of x. Okay? So let me give you some time so that you can work out this problem. Try that to see if you can do it. Okay? You multiply by 1 minus cosecant of x, and then you simplify it all the way down. I'm going to go ahead and move to the side. And I'm going to say, let me just come over here. That's going to be, see the cotangent? Let me pull it up. See the cotangent. This cotangent is a square. So that's the same thing as cotangent times cotangent. And I'm canceling one of the cotangents. And then this is a negative cotangent. Well, I just put in the negative on the front. Okay? Why is that? Well, because when I distribute, that's going to be negative 1 and that's going to be positive cosecant of x. And isn't it that what you have on the problem? What you have on the problem is just cosecant of x. And I don't have space. For some reason, this doesn't want to move up anymore. But let me just move it to the side. Can I move it to the side? Yeah, I can move it to the side. Okay, there you go. Good. So this is the same thing as cosecant of x minus 1 is equals to, that's what you have on the right? And this is over cotangent. Is the same thing as cosecant of x minus 1 over cotangent. And so the left side is equals to the right side. Okay. So that's the identity. Okay. Now let's go ahead and try number 7. See if we can do number 7.